In this next video, I want to build on things that we talked about in the first video. If you remember, in the first video, we were talking about nuts and bolts, drill bits and sizes and stuff. And here's an example of a drill bit set that I have. If this camera will zoom in properly and focus. And there we go. These are the fractional drill bits. Now, mine's getting beat up here, broken some, lost some, who knows. But most of you, if you have a drill bit set somewhere in your life at home or what, you probably have a set like this. These are Imperial drill bits, fraction sizes. So that's 1/4 of an inch, 3/16 of an inch, like that. A less common drill bit set I also happen to have. If you remember, it was the number drill bit size. And all of these drill bits have number sizes that mean something in terms of its diameter. The smallest one was a 60. My son and I beat this set up over the years. Some are broken, some are missing. It's just a bit of a mess here. And maybe someday I should buy a better set. But both of those sets I have. The third set, if you remember from the chart that I described in the first video, talk about letter drills as well. So let's see if this camera can zoom in properly. On the chart, there was all kinds of different size designations, whether it's a letter drill, a fraction drill, a number drill, and even in blue, if you remember, they were the metric drills. But this first part of the chart, which was in the red, that describes the different diameter sizes, the different set sizes, and gives their decimal equivalent up to 4 decimal places, even though normally in class we were only going up to 3 decimal places, or 1/1000th of an inch. So in this video I want to build on nuts and bolts and talk a little bit about the threads. And the threads have to do with this blue part of the chart. So I'm going to make a short video here and then build on it on the computer because I can't really zoom in so well on this one. But we're going to be talking about this area of the chart. This chart, well actually, sorry, this whole section talks about threads, the types of threads available on bolts. And I put this part in blue because it deals with Imperial threads. Basically, typical thread sizes in North America that you would see in almost any kind of a nut, bolt, or screw that you see out there. In North America, any nuts and bolts you have are Imperial. I'm going to talk about Imperial, but there are metric ones as well. In a future video, I want to talk about all the different kinds of heads and screw types and all these different things. But for this video, I just want to talk about the threads themselves. I'm going to take the biggest one. This is the thread. And really, if you look at it closely, you probably realized before nuts and bolts, threads are really just spirals. It's just this spiral that goes all the way down the bolt. And if you have a nut on it, when you turn, it just sort of climbs up the spiral. So back to something we talked about, I think, before in class. When you look at nuts and bolts, a little bit of a sex education thing, but you have male threads and female threads. So in nuts and bolts, that's considered a male thread. I think you can guess why. And the thread inside the hole is a female thread. And then there's this mating going on where you have the bolt going into the nut. Now, these threads come in standard sizes. Okay, in any kind of Imperial measurement system for nuts and bolts, there are standard types of threads. And basically it has to do with the diameter. If you take if you take a bolt and you measure the diameter, you will get one of the common fraction sizes. Now this camera is zinging in and out here, but you're going to have to trust me. Sorry, I'm jumping around the camera. But that diameter size is 3/8. So the diameter is 3/8 of an inch, and if you look on the chart, you'll look it up to 3/8, 375 thou. That nut is also a 3/8 thread, and then they meet up. If I take a bigger diameter, it's also going to be a standard diameter. So you look on that size, and in this case, it's just under 1/2 inch. just smaller than a 1/2 inch. So this would be a 1/2 inch bolt. Take this one, it's a bigger diameter. You're going to have to trust me on the video, but it's just under 5/8. So when you're measuring a nut or a bolt or screw, the diameter will be one of the common fraction sizes. And there's certain ones I'm going to show you on the chart that exist in North America. If you measure it, like I did for this one, it's just under a 1/2 inch. Any bolt that you measure will always be just a little bit smaller than the fraction size that it has. And the reason is, if it was exactly that diameter, the male thread would have a hard time fitting into the female hole. So they always make the bolts just a little bit smaller than the actual diameter. If you go on something else and you measure, again, I know it's 3/8, 375, but it's just a bit smaller, just so that it would fit in. Okay? So I'll show you on the chart how that diameter thing connects. The next part though, all threads have a certain number of spirals per inch. So I'm going to set the dial caliper at 1 inch, just so you can show as a reference. And if I have it at 1 inch, when I hold this against a bolt, in that 1 inch span, there will be a certain number of spirals that go around per inch. And that's a designation, and again, it'll make more sense on the chart when I show you, but the number of spirals per inch of thread defines the bolt size. In North America, when you use Imperial bolts, there are two kinds of threads. Sorry, I got this mixed up. There are coarse threads and fine threads. If you look at these two bolts, they are the same diameter. They're both 3/8. Now I hope I can make the camera show this. If you look at the spacing of the threads, the bolt on the top, this one up here, this one, has less spirals per inch than the bolt on the bottom, this one. So when it has less threads, it's called a coarse thread. It has less, it's coarser, there's not as many. And when it has more spirals, they're closer together, they're a little bit smaller, they're finer, if they can call it that. So they call this a coarse thread, and they call this a fine thread. And that designation is going to matter when I show you the chart. When I go online and I show you this chart, because this designates all of the standard nuts and bolts in North America, either by fine thread or coarse thread. And I'll explain that in the video. But suffice to say, there is a huge variety of bolt sizes, but in North America, they're all they're all Imperial bolts, and they will always be either a fine thread or a coarse thread. Everything you see in the camera is coarse thread. I really had to look through my stash to find a fine thread. Fine thread bolts are not that common in North America typically. So it was a bit of a struggle. I actually was surprised I had one. I found it somewhere. I don't even know why I have this, but everything here is a coarse spiral thread. Probably mixed up somewhere in my stash of nuts and bolts are some metric threads. Some from my old motorcycle or somewhere got mixed up. I struggle too. Sometimes I look at them and I'm like, what is that? And it's not always easy to know if you have an Imperial or a metric thread. But the easiest place to take a little guess is by measuring the diameter. If you measure the diameter and it's a standard Imperial fraction, it's a pretty good guess that you have an Imperial bolt. So I'm going to stop the video, jump over to the computer, and build on that idea. Okay, I'm back on the computer and I have that chart that we talked about. And in the first video, if you remember, we were looking at just what's in this left red square, and we talked about the drill bit sizes. So you have basically 4 types of drill bits: shown in this chart. The traditional ones, if I can zoom in here, let me just go here. Right here, for example, 3/8, that's a fractional in the imperial system, and it gives you the decimal equivalent, okay, if we do that. And then the next less common but next popular way of measuring in the old imperial system is that letter drill. So we had letter drills from A to Z, and that decimal equivalent, the diameter that they had. Then we had the number drill. So that was kind of the reverse. If you go over and have really big numbers, you get really small drill bits. And if you have really big numbers, really small numbers, you get big drill bits in terms of diameter. The chart also shows you the metric drill bits in blue. I don't have any, to be honest, I've never seen a metric drill bit in Canada, but I'm sure they're out there if you go to buy them. And the decimal equivalent in thousandths of an inch. So building on that idea, I want to jump to the next part of the chart, and I've outlined it in blue here. And I'm going to zoom in even closer. And what I want to look at is, if I can zoom in here, I want to look at this part of the chart in blue, and I'm really just going to look at the first two columns for now because it connects to the idea of nuts and bolts and thread sizes. And maybe into the third video I want to talk about the tap drill size and this alternate tap drill size. Down the first two columns, they call it the tap size, or what I'm going to call the thread size. And the pitch is something I already talked about in the video part from my workbench. I'm going to go down to the common sizes that are probably familiar and try to explain what you're looking at in the chart. In the video I made on my desk or on my workbench, I had those nuts and bolts. And for example, I had a 3/8 bolt. So it's highlighted right here. That's the pitch size, or the diameter of the bolt, 3/8 of an inch. I could look over what the actual decimal value is. Well, there's two types of 3/8 bolts. NC, coarse thread, so the C here stands for coarse, and NF, the F stands for fine thread. The N stands for national. And what does that mean? Well, the easiest explanation I can think about is electrical plugs. I'm going to guess we've all seen this somewhere in the world, these different kinds of electrical plugs in different parts of the world. And why do we not have them all standardized? Why don't we all agree across the world to have a certain type of plug? So in North America, this is very common. In parts of Europe, you'll see this. And then, I lived in Asia. It was the round one, I believe, or something. It was, I can't remember. And then I lived in Africa, different ones. And you have all these different plugs that have to match up with them. In a sense, way back in the Industrial Revolution, when they built nuts and bolts around, very quickly people started realizing, hey, you guys over there in Asia somewhere, you're making nuts and bolts that don't have the same threads like our nuts and bolts. So if I zoom in on this one, you can see, if you want your nuts and bolts to match up with my nuts and bolts, then shouldn't we agree that we all have the same number of threads, the same diameter, the same everything? And I think, there are different places in the world, they started realizing this problem probably about 200 years ago or something, at the beginning of the Industrial Revolution. Well, that's where the ends comes from, national. The nation, or the nation of Britain, I guess, came up with their system. Now, I'm not saying other parts of the world didn't have a system either, but because of the Industrial Revolution kind of sweeping through Europe and the British pushed hard for the imperial system, they came up and said, hey, if we're going to make nuts and bolts, we better all agree on a national standard. Make sure we all make the same kinds of threads. And that's where this comes from. So, I don't know, historically, 200 years ago, everyone in Britain said, hey, you're going to make a bolt. If it's this size, the diameter will be 3/8. If you need a smaller one, you can make a 5/16, or you can make a quarter. If you need it bigger, you can make a 1/2 inch, or whatever. So they all agreed on those. Then they agreed we're going to make them two types, because for some applications I need a very fine thread. So that's where the nation agreed to have a fine thread, or the nation agreed to have a coarse thread. Then someone had to decide, well, okay, we want a coarse thread. How many spirals do we want? 16. Don't ask me where 16 comes from. I have no clue. But someone way back decided if you're making a 3/8 bolt, it's going to be a coarse thread and 16 spirals on it, 16 threads in 1 inch, like I showed in the workbench. If you have 1 inch of thread on a 3/8 bolt, it will have 16 spirals, and that's coarse. If you want a fine thread, you make it 3/8 diameter and you put 24 threads on it. Don't put 23 on, don't put 25 on, put 24 on, because we said so. We're the nation, or whoever the authority was, and that's what it's going to be. You don't like it? Too bad. That's the standard. 5/16. You want a coarse thread? 18 spirals. Not 17, not 19. 18. Got it? Everyone agreed. If you want to do a fine thread, 24. Okay? Now, as you go up, the bolt sizes get bigger. And they came up with all these standard sizes. Nobody makes a bolt between 1/2 inch and 7/16. It doesn't exist. You don't have them. To be honest, a student asked me once about a 7/16 bolt. I don't think I've ever seen one in my life. It probably exists somewhere, I don't know, but it's on the chart. It must exist. I've never seen a 9/16 bolt. 5/8, yes. 3/4, yes. Have I ever seen a 7/8 bolt? Don't think I ever have. Not saying they don't exist. They're on the chart. They are a national standard size, but it's just not there. So, funny things start happening here. And here, say the 1 inch bolt, coarse, fine, NS. I don't even know what that means. I've never looked it up. But obviously, a coarse thread has 8 spirals. A fine thread has 12. So is S stand for super fine or something? It has 14 spirals. I don't know. Anyways. So you can start to make sense of what this chart's trying to tell you about. Now it gets even weirder. Typical British thing, I always use the analogy of the French verbs. You think you have it all figured out, and then someone puts a new exception in. As you get smaller, the bolts get smaller, 5/16, quarter. And then for some crazy British reason, they stop using fractions, and they come up with these numbers. I don't know. But what I do know is they call it a 12/24 screw, and that's the coarse one. The 12 has a certain diameter, and I'm sure if I looked it up somewhere on the internet, I could figure out what that measurement is in terms of thousandths of an inch. But if you go to Home Depot, I have some in the classroom. I have 10/32 screws. I have 10/24 screws. And that means fine and coarse thread. A 10/24 screw is a 10 diameter, whatever 10 is, 24 threads per inch. It's coarse. 32 threads per inch, it's fine. And it goes down and down. The smallest screw I've ever really identified was a 4. I know in Home Depot they were selling 440s, I think. I've never seen a screw this small. It exists, but I've never seen one. Interesting, the number 0 screw only comes in fine, not coarse. It must be pretty fine, because in 1 inch it has 80 spirals. That's a lot of threads in a short inch. Maybe things like electronics, very small watches, old clocks, stuff where there were really small screws in there, probably have something like that. So that's what this chart is trying to explain. I've put some extra questions on the bottom of this. I'm going to repost this to the classroom. So there's some more homework practice for you to use the chart and demonstrate that you've got an understanding or a learning of what that thread system is. It's really just some crazy imperial measurement system that they've figured out. Into the next video, I want to talk about this third column and what it means to make threads into pieces, and that will be on the next video.